Welcome to Ask and Learn.
Hi everyone, so what we have here is a collar that has a mass of 2 kilograms that's moving along a rod that has the contour defined by r equal to e theta. We know that theta dot, or the rate at which the collar moves along the path, is equal to 2 radians per second. What we're asked to solve for is the tangential force F and normal force N acting on the collar when theta is equal to 45 degrees. The way we're going to go about doing this is utilizing our knowledge of normal, tangential, and rotational motion, and coupling that with free body diagrams with which we will apply Newton's second law and develop equations of motion in the r and theta direction and determine these forces F and N. So let's go ahead and get started. First of all, we know that r is equal to e theta, so therefore r dot is just going to be equal to e theta times theta dot. R double dot will then just be equal to e theta times theta dot squared plus e theta times theta dot. So when theta is equal to 45 degrees, we know that theta dot is equal to 2 radians per second, and we know that theta double dot is equal to 0. Knowing these pieces of information, we can compute r dot, and r double dot, and we find that r is equal to 2.193, r dot is equal to 4.39, and r double dot is equal to 8.77. We can use these pieces of information to solve for acceleration in the radial direction, because ar is given by r double dot minus r theta dot squared, and this gives us an acceleration in the radial direction actually just equal to 0. A theta is equal to r theta double dot plus 2r dot theta dot, and this is equal to 17.546 meters per second squared. Next, what we're going to do is we're going to define an angle psi such that the tangent of psi is equal to r divided by dr d theta dot. And this is actually just e theta divided by e theta, which is equal to 1. Therefore, this tells us that the tangent of psi is equal to 1. Therefore, psi is equal to 45 degrees. Now we can use this when we draw a free body diagram. So here is our collar. Here is the coordinate system for r and theta. And here is our tangential force, here is our normal force, and this angle right here is equal to psi. So now what we can do is we can resolve our forces in the radial and theta directions. We can say that the net force in the r direction is equal to m times ar, and this is equal to negative n cos 45 degrees plus f cos 45 degrees, and that's equal to m times ar, which is actually just equal to 0 because ar is equal to 0. Next, we can do the net force in the theta direction, and that's equal to m times a theta, and that is f sine 45 plus n sine 45, and this is equal to m times a theta, and we saw that a theta was 17.54 meters per second, so we'll put that in there, 17.54. Now, as you can see, we have two equations with two unknowns. Now, simultaneously solving these equations gives us that N, the normal force, is equal to 24.8 newtons, and the tangential force is equal also to 24.8 newtons. And that's our final answer.